So yeah, homework question 5.19. We're given this information. How much heat is liberated from 2.45 e to the 2 grams of silver? And when the silver cools down from 90 degrees to 25.5 degrees Celsius, given that the heat capacity of silver is 0.235 joules grams times degrees Celsius. And then this is one thing that I find frustrating with Top Hat is that they say heat liberated implies that the change in heat is negative. Enter a positive number. I would prefer just leave it as a negative number because we're losing that heat. But that's one other trick that, or one other mistake people have made, because the calculation to find my delta T is always final minus initial. Right, so to find my delta T, my final temperature is 25.5 degrees minus my initial temperature, which is 90 degrees Celsius. So what is that, 64.5?
-64.5, yeah.
All right, so now we can use Q equals MC delta T, right? My Q, my mass, 245 grams. My specific heat of silver, 0.235 joules per gram times degrees Celsius times my negative temperature change, 64.5 degrees Celsius. And get my calculator, helps to have. Right, 245 times 0.235 times 64.5, right? Q equals the negative 3,713.5875, sure. So the one trick, and this is maybe why you got the question wrong, was that it asks for the heat in kilojoules. So yeah, just one more step. So I know for every 1,000 joules, I have 1 kilojoule. So I divide that by 1,000, and my heat will be, negative 3.7. And then let's look at significant figures. Significant figures, we've got 3 significant figures here. So to report this to 3 significant figures, yeah, I would say 3.71, right? E to the 0. Kilojoules. And then because they want the absolute value, right, 3.71 e to the 0 kilojoules of energy. So that was probably it. It was just the last step, the conversion.
Yeah, that makes a lot more sense.
When you plug it in, why did you take the negative out?
I mean, I used the negative in the calculation, but the last sentence of that question, they say no heat liberated implies the change is negative. So they're just asking for the positive value of it. And that's why I was saying, like, that's my kind of frustration. I would just prefer that they would leave it as a negative number and not confuse you with why am I using a positive when I'm losing this energy, right? I'm going from 90 degrees to 25 degrees. The only way to do that is release energy, to have a negative change in energy.
So if, let's say on the exam, I just put negative, would I lose points for that?
I'm not going to give these, like, I wouldn't say, okay, because you're losing heat, that it already implies that it's a negative, just give me the positive number. I would just ask for the number, and I'll go in and see how people answer it, but I'm not going to have you be changing the number. If we're losing it, it's a negative number. If we're gaining it, it's a positive number. Was it 19 and 20, or was it a different question?
Yeah, 20. So like I know that absorbs heat, like, which is gonna be endothermic, right? So would you add the 2 temperatures to like find your initial, or do you still like just subtract? Oh wait, they just give you 1 temperature, right?
Yeah, so let's see, a sample of sand initially, oh no, they give you both temperatures.
Oh,
Yeah,
okay.
initially
Yeah.
at 21.5 degrees, it absorbs that much heat, the final temperature, and they give you the heat capacity. So yeah, we go from 21.5 degrees all the way up to 67 degrees Celsius. So this one's a positive change in energy, right? And our delta T for this is 45.5 degrees Celsius. All right, Q equals MC delta T. This is a little bit different that now we know Q. They said that Q is 1400 joules. That's added to a mass of sand. I don't know the mass of sand, but sand has a heat capacity of 0.84 joules grams degrees Celsius, and my delta T is 45.5 degrees Celsius. So multiply those two together, 0.84, 45.5 divided across.
Where did
and
you get the 1400 joules?
So maybe this number is a little bit different in your question, but mine, it says the sample of sand initially at 21.5 degrees absorbs 1.400 e to the 3 joules.
Okay, yeah. Mine is just slightly different, so thank you.
Yeah, so that could be a little bit different in your question. So my mass equals 1400 joules divided by 0.84 joules grams degrees Celsius times 45.5. So mass equals, let's see, 14 divided by 0.84 times 45.5. And so I get 36.63. And then for significant figures, I think I would only go to 2 significant figures because this temperature that we're measuring is 6.7 e to the 1. So that's just 67. That's 2 significant figures. So I would say that my mass is 3.7 e to the 1 grams of sand. Right, we're going to only report 2 significant figures, so I would drop everything after that, and because I'm dropping a 6 is greater than 5, so I'd round that up to 37, and then 37 in scientific notation, 3.7 e to the 1.
That makes a lot more sense, thank you.
Yeah, so these questions, you'll always have 3 of the 4 unknowns. So this time we were finding mass. I could ask you to find specific heat. We found Q. So yeah, you would be given 3 of those 4 and be asked to find the other.
Okay, thank you.